Students, this is Dr. Kaur, and I'm going to show you how to do Lab 2 Plate Tectonics Lab with seismicity and the volcanism. Okay, so I'm going to share my screen now. So you can see here, there are 7 steps that you need to follow very carefully. And if you jump over those 7 steps, you are not going to get the results that you are seeking. So by clicking the Google Earth link, upload the Google Earth and then install it on your computer. And then this number 3, 4, 5 are very important, that you go through them and do exactly what they have said. And then in step 5, you're going to upload the dynamic Earth KMZ files. And once the KMZ files are loaded, then what you're going to do is move them from the temporary places to my places. And I'm going to show you that also. So I'm going to stop sharing the Word document and bring up my Google Earth. All right, now you see the Google Earth view of this. So what I was saying is that when you first upload it, it comes under these temporary places. You move by dragging it from here, you move it up to under the my places. So that's where it is. So you need to do that. And then once you do that, then all this will come up and you can see that if this is highlighted, then I can turn on and off a certain few things. So this is the normal view of the Google Earth. It actually shows you the plate tectonics feature, because from space we can see some of this feature of the large scale. So what you see here is the Indian Ocean, and you can see the Indian plate. This is the boundary of the Indian plate. On the south side of the Indian plate is the east and the Indian ridge. Sorry, this is the Indian ridge, and you can see how, and this is the subduction zone. The Pacific plate comes here. This is the Indo-Australian plate, and you swing around, and this is the largest of the plates. It's the one of the, not the one of the, it is the largest plate. This is the Pacific plate. It's mostly an oceanic plate bounded by a lot of subduction zones where the Pacific plate is being lost. So if I turn on the ocean floor edge, then you will see that where the mid-oceanic ridges are, the divergent boundaries, that's where the youngest of the rocks are going to be. That's where a new ocean crust is being created. So if I go to the Atlantic Ocean between Africa and North America, South America, you can see very clearly the Mid-Atlantic Ridge, the North Mid-Atlantic Ridge, the South Mid-Atlantic Ridge. And this is where new plates are being created. So yeah, if I turn on the edge now, so here is the seafloor edge. I turn it on, and you can now see the red indicates 0 to 10 million years. So that's the youngest of them. And as you go away from the ridge, on 2 sides of the ridge, there's a mirror image of the seafloor getting older and older. And the oldest rocks are at the 2 continents. So this is very clear that what Wagner had said when he drafted continental drift, that he saw that this part of South America fits right into that part of Africa. If I zoom out, you can see that very clearly. Or this part of South America, Africa fits very well with this part of eastern part of North America. So this was the concept of continental drift, which he could not prove at that time. The seafloor mechanism of spreading was not known. That only came up in the 1960s with technology. Now we know that in the middle of the oceans runs either a ridge or a rise when tectonic plates are being created. All right, now you can see the edges of this. Now, if I turn on here the volcano and my plate tectonics, the dynamic earth part, and then you will be able to see the seismicity one. So if I go and click on that, so you see 20 years of seismicity. And then if you zoom on, then you will see each one of them where the seismicity are. So these crosses are where the size, they are not random. You would not find seismicity generally in the interior of a plate. They will mostly be on a particular area. So let me just click on one of these. So this is all the magnitude 6 or above are located here. So this is this Ascension Island region. This is where I did my PhD, this volcanic island, and I studied the volcanism of that island. So this is a magnitude 6 earthquake that happened in 2011. Its depth was 10 kilometers. And if I go to that's the earthquake. If I go to the volcano, which is the Ascension Island, and click on it, now you can see that it's a stratovolcano. It has cinder cones and lava domes, and it gives you the latitude, longitude, and a brief description of the volcano. So you can go now, if I zoom out, you can see what the volcanoes are, what the earthquakes are, the crosses of the earthquakes, the triangles of the volcanoes. They are not random. So they are occurring at very, very specific areas of the world. And so if you look at the North American continent, you will see that North America is bounded on the west side by a subduction and a transform fault, the San Andreas fault and the subduction zone. And in the East Coast, where we are in Georgia, there is no plate boundary. The plate boundary on the East Coast is in the middle of the Atlantic Ocean. So the North American plate runs from middle of the Atlantic Ocean all the way over North America and ends on the West Coast. So this whole area is bounded by, different types of plate boundaries, the 3 types. So on the east side, it's all, here is the mid-Atlantic ridge. So this is the spreading center, divergent boundary. On the West Coast, there are 2 types, where California is, that's a transform fault boundary. Lithosphere is not being created or destroyed. They're just moving past each other. And on the top where you see Wanda Fuca, so if I go and zoom on that area, this little plate is being created there. This red means it's very young age. And then the plate is being subducted under the North American plate. And you have this series of continental volcanism from ocean plate going under a continental plate. So if I go to like Mount Hood or Mount St. Helens or Mount Rainier, so let's look at one of these volcanoes. So Mount Rainier, so it's a large stratovolcano, pyroclastic cones. So it looks ominously, if you ever go to Seattle or Portland, it's just like right there, but it's 90 miles away and it looks ominous to this. These volcanoes are very dangerous. They are subduction related, so they erupt a lot of intermediate to felsic volcanism or magma comes up in this area. So these magmas are very viscous, so they can't flow. So the volcano just literally bulge up when the magma comes up and then explodes in this huge, gigantic event. So these volcanoes are very, very dangerous, which have very viscous magma. On the other hand, if you go to the middle of the ocean where the mid-Atlantic ridges are, these are mostly passive volcanism, where the magma is very fluid. So the viscosity is low. Viscosity means the resistance to flow. So glue has very high viscosity, water has low viscosity. So the magmas that behave like glue can't flow. So those are the dangerous magmas. So when they erupt violently. So here you can see the Gulf of California, and you can see there is a spreading center here, and these lines are transform faults, and you can see earthquakes occurring in and around these areas. So earthquakes don't generally occur. And what are earthquakes? Earthquakes are sudden release of stored energy in the Earth's crust. So when a bulk moves, it creates the earthquake. So you can see where the plate boundaries are, the earthquakes are, and the volcanisms are. There are some examples of volcanism. So here's the large Pacific plate, but right in the center of it is Hawaii. So why is Hawaii a volcano, and there are earthquakes and volcanism in the middle of a plate? So this is related to what you call a hotspot. Hotspots are very deep seated magmas that comes from very deep earth, and so they can pop up anywhere. It doesn't have to be a plate boundary because their sources are so deep. And you can see this is all the islands of Hawaii. The newest islands are here. The one that is forming even now, it has just Rogaluhi, would be the future Hawaii. And today, the big island of Hawaii, you can see here marked, has a few volcanoes on it. And as the Pacific plate moves like a conveyor belt over the Pacific, over the Hawaiian hotspot, you can see the older and older Hawaiis as we move west. So these are the older Hawaiis, and as the crust becomes old, it becomes dense and it sinks. And on the volcano's weight also makes it very difficult. And so becomes it very heavy. So the crust sinks and the volcano sinks, and finally the waves pounding on it, weathers it out, and finally it becomes what we call a atoll, or like a coral island. So you can see this, how the volcanoes of the Hawaiian plate is moving, Pacific plate is moving. And then there is a northward movement where it disappears into this Aleutian Trench. So this is the southern part of North American plate. You can see we go all the way to Japan and to Russia. So the North American plate and North American continent are two different things. And all these volcanoes and earthquakes, and this is what is called the circum-Pacific belt of Ring of Fire. So this is the chain of islands. So all of Hawaii, all of Japan, Indonesia, Malaysia, these are all volcanic islands. So anyway, this is how you do it. Answer the questions and then turn it in. All right, so here is a global view, and follow those steps to get the Google Earth to work, okay?